Hey class, welcome back. If you check out the board behind me, we're going to talk a little bit about what we're doing here in week 12. We are in the second trimester now, and we will start off with fossil fuels. We're talking a little bit about renewable versus non-renewable resources this week. We are still in chapter 3 of our textbook, but remember, since we see each other online only 2 days per week instead of the usual 5, we're kind of condensing and picking and choosing some things to make sure that we get all the science concepts across still, but we're making sure that we really focus our lectures and what we're doing in class so that we get everything in with the time that we have available online. This week we're talking about this rock right here. Not only just this rock, but coal, oil, and gas. This particular hunk of coal came from my grandfather's backyard, and we'll talk about that in a second. We'll also talk about why I've got a golf club today as my pointer instead of the usual lightsaber, which is sitting over there, but the golf club is going to be my pointer today. We start with the brain pop on fossil fuels, and the brain pop on fossil fuels, as always, the students are asked to pull out 2 facts from the brain pop. In this case, 2 of the facts might have been that renewable resources are things like solar, nuclear power, wind power. Those are things that we can rely on as being available tomorrow and available in 1,000 years. Non-renewable resources are just like they sound. Non-renewable resources are being depleted. So when I hunk of coal I just picked up a second ago, there's only a limited amount of coal. So we'll talk a little bit about that. As far as the nitty-gritty, the homework this week and what we have due, don't forget Wednesday tests. We always have our weekly tests due by Wednesday at 3 o'clock. That's consistent across the second trimester. It was very consistent across the first trimester too. I think we had one time when the test was due a day later because we had a day off that week. But I want to make sure that we keep it to the same day whenever possible so that you know, hey, on my Google Calendar or whatever calendar that you use, hey, 3 o'clock on Wednesday, did I get my test done? Oh, yeah. So put that in there. Make sure you check it on off. There will be it says Friday, define all the definitions that you see up on the board. The things to define this week are boxed in red and they're underlined. And again, those will be out there on the notes. Don't forget to go to pacificascience.org for the notes if you've missed anything. Your student notebook should always be updated all the way back to the first trimester. Make sure you have all the notes updated. And also it says homework or reading. I want to summarize things in a reading that I'll put out there today. Kind of summarizes what we did with the dinosaurs and a little bit with chapter 3. All right, jumping back into the notes, we wanted to talk a little bit about biodiversity. You already have. You might remember that we had the producers right here on the school yard. I showed a little bit of the grass outside. The photosynthesizing producers, the grass, eaten by the herbivores, the geese, the Canada geese that are out there, Canada goose, I should say. If you check out the Canada geese that come on by, they might get eaten then in turn by a coyote, a first level carnivore. And you've got a food web or a food chain. They refer to it in 2 different ways, both in our textbook and in our readings. And the point being that if you have a species suddenly removed from that food web, if you have several species all of a sudden dropping out because they've gone extinct, that's when food webs collapse. That's when you have a huge drop in biodiversity, and it can lead to what the textbook talks about and our note has up here, mass extinction. There's no exact percentage when you've already hit a mass extinction, like 50% or 60%. Generally, scientists say when you have more than half the species gone, that's a mass extinction event. In the history of life on Earth, remember, life has been around on this planet for 4 billion years, roughly. In that history, we've got 5 mass extinction events. Most scientists agree that right now we are in the midst of, it's happening right now, a 6th mass extinction. We'll talk a little bit about the whys of that and a little bit about how we can put the brakes on that. That's very, very important. That's one of the themes across the NGSS, the Next Generation Science Standards, and it's one of the things that we're going to talk about quite a bit in this class. How do we stop this? How do we stop a 6th mass extinction from happening right now? An extinction, of course, is when you have a species that's completely gone. And one of the biggest things that cause extinction is when you change the pH. Notice it's one of our key terms. We'll go into it in more detail next time and also in our reading. But the pH is the acidity of the oceans. Currently, because of burning things like coal and oil, we are greatly increasing, or I should say dropping the pH of, or greatly increasing the acidity of the ocean That affects the base of the food chain. That affects the photosynthesizers at the base of the food chain. One of the things that we're going to check out in the next slide is something that you've already seen in your first trimester notes. So this is another example of where it crosses over. We want to make sure that we have our notes available. Let's check it out. It talks about chemical bonds and carbon. And I'm going to push this off to the side, grab this one, bring it on over. And you've seen this before. Again, we know that sunlight, nuclear energy, is releasing the energy stored in the strong nuclear force. That energy reaches the Earth through electromagnetic radiation, fancy word for light, and that gets stored in plants. We've studied plants already a little bit as the primary producers on this planet. And if you look at, for example, our leaf rubbing, we know that it takes water, it takes carbon dioxide, rearranges them to make sugar, and releases oxygen into the atmosphere. Here's where we get into a little bit of that chemistry that we talked about earlier in the year. Remember the periodic table of elements. The element that you want to check out is carbon. Carbon is the most important. It's one of our key terms up here, element number 6. It's sign language for 6. And when I got my chemistry kit, when I was in junior in college doing organic chemistry, I'm going to reach over here and grab the front of the kit right here. And I have the whole kit sitting on the table, and the table has all these little marble-like things out of it. And I remember very clearly being, somewhere around 19 years old, thinking, organic chemistry kit, I'm in college, that looked like a little kid's kit to me. Turns out organic chemists use these kits all the time. A lot of them are now virtual. But really, when you go into one of these kits, and this is what I want to show you, you've got these little marbles that represent different atoms. And of course, when you can pull them apart, the little sticks represent the bonds that they can make. In other words, and you know this already, atoms get together to make molecules. So an individual marble would be one single atom, and a collection of them would be a molecule. When you go through these kits, you very, very quickly check out, and I love these because they're visual, they're very, very cool. You see that, the white ones here in this kit represent hydrogen, the red ones represent oxygen. You've got two places, for example, right here, where oxygen can stick on another atom. This one you might recognize as good old H2O. Check out carbon. Carbon is almost always represented by a black marble in these things. Why? Well, check out this hunk of coal. This hunk of coal, carbon, oil, black carbon compounds like that, we're burning for fuel. If you check out this carbon compound, look at all the places that carbon, I'm going to pull it apart. Carbon can connect to other atoms. Using the Lego analogy from before, it's almost like the perfect Lego. It can connect to so many different other atoms and connect to itself to make these long carbon chains. You might remember that, long carbon chains or polymers. It is absolutely essential for life. Scientists have a hard time even imagining life without carbon, because carbon is an atom that can make practically an infinite number of compounds. Check out this golf club. You're talking about a golf club of all silly things. Happen to have it in the room. I use it as a pointer all the time because it's nicely weighted for a pointer. But it's made of a carbon fiber. In other words, you take carbon, you can link them together to make things like this. More importantly for us and for this class, not only does it have just amazing diversity in the things that you can build with it, it is the basis for these long carbon chains that plants use for food. And if you look at plants that have been buried about 300 million years ago, those fossils can, if conditions are just right, get turned into carbon, get turned into coal, oil, and gas. If you look at coal, oil, and gas, it has been an absolutely tremendous party for the last couple of generations on this planet, burning coal, oil, and gas. It is incredibly easy to use this as a power source. It seems, for example, that when you turn on your computer, you're looking at this on an electronic device right now, you think, well, we're probably getting that energy from solar, from nuclear. And yes, sometimes, but for the most part, for the world as a whole, we're still getting more than half of our energy from burning this rock. That's kind of amazing when you really think about it. Gas, coal, oil used to be incredibly cheap. In other words, I remember when I was about your age. In other words, this is for the 7th graders in my class, taking $1 down to the store, and we had a gas lawnmower of all silly things. When I was a kid, my dad would say, hey, the gas can, which holds 1 gallon, is empty. Can you go fill it up at the gas station? And he'd give me $1, and I would run down with the empty gas can, fill up the gas. And the thing is, with that $1, not only would I fill up the gas can, I had change left over to buy a candy bar at Cappuccino Market. In other words, I could take $1 and get a gallon of gas. You probably know that a gallon of gas now is up around $4 or $5 depending on where you live. The point being, gas has been going up in price partly because it's a non-renewable resource. There's only a limited amount of this stuff. I worked for a number of years for an oil company, and one of the things that they're constantly doing is taking the oil, they refine it. For example, at the Chevron Richmond refinery, if you've ever driven by the refineries out there in Richmond, California, which is just a few miles away, you see all these stacks and tanks. What they are basically doing is taking the oil, basically boiling it. That's what a refinery does. You get these different levels of petroleum products from it, and you might remember that some of it is used as natural gas for, say, barbecuing. Some of it is used, of course, for gasoline for cars. Some of it in the form of fuel oil we burn for electricity. It's still a very, in many ways, archaic way of getting our electricity, burning a rock, essentially. The most important takeaway from today is that this is limited. As easy as it is to simply mine coal or pull up oil from the ground, it's an incredibly dense source of energy, but is limited. We're running out. Eventually, this will be used up. And that's why we're going to focus on renewable energies next week and next Thursday in class, because there's only a limited supply of coal, oil, and gas out there. One of the other big drawbacks of coal, oil, and gas is pollution. When you're talking coal, oil, and gas, the carbon dioxide that it sends up into the atmosphere mixes with our oceans, bringing down the pH. We'll talk a little bit more about that. It's also in our reading, but it makes the oceans more acidic. When that happens, you're hurting the photosynthesizers in the ocean, the plankton. You also might remember from last week, we talked a little bit about how plankton is also getting displaced by plastics in the ocean. And the last little thing about pollution here, again from chapter 3, is you make plastics with petroleum products. You make plastics with oil. And these carbon compounds are incredibly awesome as far as being able to be molded into a million different things. But on the flip side, when you're making plastics, they're also extremely durable and they never go away in the environment, or they take a very long time to go away in the environment. So one of the big things that the NGSS that we're focusing on in here as well is how do we address these pollution problems caused by our use of oil and gas. Oil and gas has been great in terms of fueling our economy. It's been wonderful in terms of being a fantastically cheap and reliable power source. But at the same time, we have to address some of the pollution problems that are happening right now. You young people are the ones that are going to help solve this, because we have to figure out what do we do with the waste products and what will replace coal, oil, and gas for the next generation. That's where we're going this week. Please look for the notes online. Go to pacificascience.org, and I'll see you next time online. Bye-bye.